This recording is for a 1 proportion z interval. We already worked this one in class, but I thought I would make a video of it because it's one of the first times we're doing one of the 4-step problems. So by 4-step, I mean we are doing state, plan, do, conclude. So we want to walk through all 4 steps. You know you need to do the 4 steps because this just generally says construct and interpret a confidence interval. So anytime it just says that statement, you need to do all 4 steps. So let's go ahead and dive in. So I start with the state step, and usually this is typed for you. So you want to look for it, and it happens to be roughly right there. So we want to say something about the true proportion. So the true proportion of red beads in the container in Mr. Vignolini's class. Then you just move right into the plan step. If this was a hypothesis test, we would set up some hypotheses, but this is a confidence interval problem. So 3 things need to be said in the plan step. You need to say that it was a random sample, although they never say, they're just referring to a previous problem. So we're going to assume a random sample was taken. If you look at the request, construct and interpret a confidence interval, it's obvious they want us to do it. If they asked a question like, why can we not construct one, then I would say possibly because it wasn't a random sample. But it's obvious they want us to do it, so we're going to assume a random sample was taken. And sometimes it's tricky to see what the sample is. It's not 3,000. That's how many are in the whole container. But they sampled 107 red, 144 other beads. So that adds up to 251 beads. That was their sample. So sample size was 251, and the sample proportion, we're interested in red, is 107 out of 251, which comes to 4263. So we also need to make sure that the sample was not greater than 10% of the whole population. This one's a very finite population, so it's nice to check. So N needs to be smaller than 10% of the pop, which 10% of the population would be 300, and that one is. So it checks out. I don't think we need to say more than that. The critical one that we need to make sure we show is the large counts. So we are going to show that NP is greater than 10 and N1 minus P is greater than 10. Since it's a confidence interval, we have no idea what the true proportion is, so we're going to use the sample proportion. When we move to hypothesis testing, we'll move back to using P, the true proportion, or the claim of the true proportion. So, if you already see what the number of successes and failures are, that's the result of this. So you're welcome to go ahead and write that down. I'm going to write every step, though. So we have 251 times 107, 251. The 251s cancel out, and 107 is bigger than 10. The complement will be 144, but feel free to show it if you want. You don't have to, but it should be the number that adds up to 251. So if you were to type all this into your calculator, you should end up with roughly 144. And now we know the sampling distribution is approximately normal. All right, let's move to the do step. All right, do step. You can get away with either writing the formula or naming the interval that you're constructing. So here's the formula. Or, I promise, I am A-OK with this, and AP is A-OK with this. 1 prop Z interval. You are A-OK to write either of those for full credit. Z is going to be 1.96 because of the 95% confidence. So if you go to table B on your formula chart and you look at the very bottom row, it's the infinity row. So one more time, table B on your formula chart, the very bottom row, so you have to flip to the back of table B, look at the infinity row, look at 95%, and then right above it is 1.96. We know p hat is 4263. We could plug that into that square root standard error and get it, but I'm just going to use the calculator. So on the TI-84, you would, on a blank screen, press Stat, go over to Tests, and then scroll down till you see 1 prop Z interval. On my TI-84, it's option A. And then you type in red beads for X, so 107. Type in 251 for sample size and 0.95 for confidence level. For X, don't type a proportion. It'll probably error out if you do that. So on the Inspire, you would go, oops, why did it do that? Okay, menu, stats, confidence intervals, and 1 prop Z interval. 107 red, 251, and 95%. So we're going to write down the lower to the upper. Make sure you write lower first. For some reason, some people like to write upper first, and that makes no sense. This is an interval, lower to greater. And you're welcome to write that margin of error down, but you're not required to. So back to the document. Our interval is 0.3651 to 0.48. That's a funny looking comma. Let's rewrite that. 0.4875. And now we can conclude and be done. Need another color. So this is something you need to memorize. You lead with what's your confidence. We have 95% confidence in this case. That the true, and this is where you just basically copy the state step. True proportion of red beads in the container. We already talked about the teacher's name, so I don't think you need to restate it. You can if you want. Is within 0.3651 and 0.4875. All right, hope that helped. I'll post another one about sample size soon. Bye, y'all.